Okay, guys, so I hope I can finish up this worksheet in this final video. Let's hope. So I've talked about the first few. I want to come back and talk about something like calcium hydroxide or barium hydroxide, because all of our strong acids only have one ionizable hydrogen that completely dissociates. The second one does not. So the first one's a strong acid and the second one's a weak acid. But in something like barium hydroxide, the first and the second are equal. So if I have barium hydroxide dissociate, I get barium ions plus I get 2 hydroxide ions. So if this is 0.275, this will be 0.275 molar. But what is this going to be? It's actually going to be 2 times that, isn't it? So I'm going to take 0.275 times 2 equals, and I get 0.550 molar. And I do need that final 0 because I have 3 significant figures, so I need 3 here. I've only done multiplication, so it's not a matter of what column or anything else. It's just 2. So now my POH is going to equal the negative log of 0.550 molar. And when I do that math, negative log 0.550 equals, and I get that my POH equals 0.2596. I have to keep this third spot, so it's going to equal 0.260 is my POH. So 14 minus that answer is going to equal 13.740. And the next number is a 3, and so this would round to 13.740 is your pH. And that makes sense because I've added a base. I should get a pH number that's above 7 because this solution needs to be basic. One check you might want to think about at this point when you get a number, look back and see what you put in solution. If it's a hydroxide, you have to remember that this is not the correct answer for pH. That is POH. This is pH. So what if we had something like H2SO4? That first hydrogen completely dissociates, and when I write this reaction, I will get hydrogen ions plus hydrogen sulfate ions. Then this one can dissociate some more, and so I can come over here and write it as a reactant. Now we have an equilibrium where we get more hydrogen ions plus this sulfate ion. Unless I tell you, this question would be something we would deal with later. So if you see something that has a 2 on it, it's almost always going to be a hydroxide, and you would have to do both of those and double it. So things to remember when you calculate, or you're given a base, you're going to calculate POH, and then you're going to take 14 minus the POH to give you the pH. I typically ask for both the pH and the POH. So you have to remember that if you have a base, you're going to get POH. If you have an acid, you're going to get the pH, and then you would take 14 minus the pH to get the POH. I think that's pretty straightforward. And I think this covers everything that you need to know in this unit, in this worksheet. So hopefully this will help. Thanks for listening.